Thank you for tuning in. This is Lance, your host of Strange Bites, where we take real science and wrap it up in a creative story and serve it in 15 minutes or less. If you're enjoying the show, please hit that subscribe button on your favorite podcast app. Give me a follow on social media. And now, let's jump into the next bite. You're staring up at the night sky from somewhere quiet, maybe the hills above the bay where the fog rolls in like a living thing. Most stars are pinpricks of white, but one faint dot glows soft, impossibly pink. For years, astronomers knew it was there. They even gave it a nickname, the Pink Planet. But it stayed silent, too dim, too far, too strange for our best earthbound eyes to read its secrets. Then in 2026, something changed. A telescope in space, one with infrared vision sharper than anything before, finally caught its light, and what it whispered back was salt. Clouds of it, high in the sky in a world 57 light years away. In episode 39, we're not just talking about a discovery, we're stepping into the story of how light from a pink world traveled across the galaxy, got tangled in salt crystals, and forced us to rewrite what we thought we knew about planets, clouds, and the weird chemistry hiding in the dark. Back in 2013, astronomers using the Subaru telescope in Hawaii snapped the first direct picture of this object. They called it GJ504b. It orbits a star a bit like our sun, but the world itself is no Earth twin. It's a gas giant, somewhere between a huge planet and a failed star. At roughly 25 times Jupiter's mass and about 43 to 57 times farther from the star than Earth is from the sun. It's in a cold, lonely orbit, and it's youngish, maybe 2.5 to 4 billion years old, but still glowing with leftover heat from its birth. That leftover heat is why it looks pink in those early infrared photos. Not cherry blossom cute pink, more like a dull, eerie magenta. Color of something still cooling off in the void. For over a decade, that pink speck teased scientists. They could see it. They could measure how bright it was in different filters. But they couldn't get a spectrum, the detailed fingerprint of light that tells you what's exactly in the atmosphere. Ground-based telescopes just weren't sensitive enough. The planet was too faint and Earth's own atmosphere got in the way like dirty glass. Enter the James Webb Space Telescope. The JWST is basically a giant infrared eye parked a million miles from Earth, where it is super cold and nothing blocks its view. Its mirrors are coated to catch the faintest heat and longer wavelength light our eyes and most ground telescopes miss completely. In 2026, a team led by astronomer Anish Babaraj at Northwestern University pointed Webb's NIR spec instrument, a near-infrared spectrograph, at GJ504b. In just a couple of hours of observation time, compared to years of failed attempts from the ground, they pulled off something incredible. They captured the planet's light directly. What came back was a spectrum packed with molecular signatures: water vapor, methane, carbon monoxide and carbon dioxide, ammonia, even hydrogen sulfide. The data also hinted that the atmosphere was richer in heavy elements than its host star, and the chemistry wasn't sitting still. Stuff was mixing from deeper, warmer layers. Disequilibrium chemistry, they called it. But here's where it gets deliciously weird. When the team tried to build computer models of what the atmosphere should look like, the numbers didn't add up. The spectrum had strange dips and shapes that no clear atmosphere could explain without forcing temperatures or pressures that made no physical sense. So they added clouds to the simulation. Not water clouds, not ammonia ice like on Jupiter. They tested different kinds, and one type fit perfectly. Salt clouds. Specifically tiny crystals of potassium chloride and zinc sulfide, compounds more at home in a chemistry lab or your kitchen salt shaker than floating in planetary sky. These salt clouds sit high up, acting like a hazy veil. They mute the light coming from deeper layers, reshape the spectrum, and suddenly everything clicks into place. The temperature comes out at around 564 Kelvin. That's about 291 degrees Celsius or 555 Fahrenheit. Hot by Earth standards, but downright chilly for these kinds of objects. The models now make physical sense. JWST didn't just take a pretty picture. It read the atmosphere's chemical diary and revealed that salt, actual mineral clouds, was the missing piece scientists had theorized about for over 15 years. All of this from light that left GJ 504b decades ago, traveled 57 light years through interstellar space and landed on JWST's mirrors in 2026. The universe is patient, and it has stories to tell if you know how to listen to the right language. Infrared. The tech behind this discovery is mind-bending. Normal telescopes see visible light. JWST sees infrared, heat radiation, and special wavelengths that pass through dust and reveal molecules. Being in space means no twinkling atmosphere ruining the view. High contrast tricks let it separate a faint planet from a star that's billions of times brighter. Post-processing is like having a super smart friend who cleans up the photo until the hidden details pop. That's how we went from pretty pink dot to here's the recipe of the sky, including salt. So what does a pink world with salt clouds actually mean for us? On one level, it's a triumph of curiosity. We build a machine that can reach across 57 light years and decode chemistry we've only theorized about. It proves that even failed stars or borderline planets have complex dynamic weather, mineral clouds raining or drifting in alien skies. It blurs the line we like to draw between planet and star. GJ 504b sits right in that fuzzy zone, reminding us nature doesn't care about our neat categories. On a deeper level, it's humbling. We used to imagine other worlds as variations of Earth or Jupiter. Water, oceans, ammonia clouds, familiar gases. Now we have evidence of salt crystals condensing in the upper atmosphere of a cold giant. What other exotic chemistry is out there? Could similar processes happen on smaller, rockier worlds we haven't spotted yet? Could there be entirely new kinds of weather or even prebiotic chemistry we've never imagined? Light is patient. The photons Webb caught left that world long before humans walked upright. We're not just observing the present, we're reading the past of a distant stranger. Every new spectrum like this expands the map of what's possible. It shrinks our cosmic loneliness a little, while also making the universe feel even stranger and more alive than we gave it credit for. What if normal planets are the weird ones? What if salt clouds and disequilibrium chemistry are common in the cold outer reaches of other systems? And what does that say about our own little blue world? Fragile, water-rich, and currently the only place we know life exists. Future telescopes and missions will chase more of these edge cases. We'll get better at spotting smaller worlds, reading their atmospheres for biosignatures, and maybe even one day asking, is anyone home? But discoveries like GJ 504b's salty sky also carry a quiet warning. Technology lets us see farther, but it also shows us how little we still understand. The cosmos keeps surprising us. That's the bite that stays with you. Not just the salt in the sky, but the reminder that wonder and humility are two sides of the same cosmic coin. That's it for today's bite. I appreciate everybody listening. If this one gave you chills or made you look up at the stars a little differently, hit that subscribe button. Share it with a fellow weird science lover, and stay tuned. There's always another strange bite coming. Until then, stay strange. Question everything. And remember, the universe is stranger than we can imagine, and we're just getting started.